All right, so now this really comes down to just practicing the method of solving a system by substitution without graphing and showing your work. I mean, we certainly can check our answers with Desmos. In fact, I always recommend doing that. And again, solving a system is really about, whether it's substitution or any other method, is find the XY ordered pair that makes both equations true, that works in both equations. And with the substitution method, we're looking at one of the equations and making sure one of the equations is solved for a variable first, because that's what allows us to substitute it into the other equation. So you'll notice that this first equation, or sorry, not the first equation, the second equation is solved for x. In other words, x is by itself. X is equal to y plus 4. So that means I can take that and put it into the first equation. I can substitute that into the first equation for x, because x is equal to y plus 4. I can substitute it in for x. And so let's rewrite that first equation then. So that first equation becomes 5, instead of 5x, it becomes 5 times y plus 4, because that's what I substituted in. And then keep writing that equation. Minus 2y equals 26. Okay, unlike the previous page, this one's going to require a little bit more algebra. So as we solve this right here, we're going to need to think about doing a little bit of work. Actually, I'll just stick with red. We need to do a little distributive property first. So this is a multi-step solving problem. So I got to simplify first by using the distributive property. So I got to multiply that 5 times both of those terms. So that gives me 5y plus 20, because 5 times y is 5y and 5 times 4 is 20, minus 2y is equal to 26. Next, I need to combine the like terms together, because I have y's on the same side of the equation, so I can add those together. 5y plus negative 2y, so that would be 3y plus 20 equals 26. And now I've got down to my two-step equation. So just like we have done with other two steps, we'll undo it adding by subtracting, which leaves me with 3y is equal to 6. And then undo 3 times y, undo the multiplication by dividing. That leaves me with y is equal to 2. So I know in this solution that y is equal to 2. That's half of my solution. And so to get what x is equal to, I need to substitute that back in to one of the other equations. And I'll stick with the red. Notice that second equation is solved for x. So what if I take that second equation, that y plus 4 equals x equation? Now I know that y is equal to 2. So now I can plug that in. I can substitute that in. So I can put that in for y. So 2 plus 4 is equal to x. 2 plus 4 is 6. So x is equal to 6. In other words, my two lines, if I graph my two lines, I should see that they cross when x is 6 and y is 2 at 6, 2. Let's go ahead and check that out. And so now I can put that in. All right. So 5x minus 2y equals 26 in the first equation. Y plus 4 equals x for our second equation. All right, so there we have the two lines. They are going to be crossing at 6, 2. So instead of pasting in our graph like we did before, I'm just going to use it like you would in a problem, like if you were just checking your answer. Now I can see that my solution is 6, 2, and so now you know that you did that correctly. Good work. All right, let's do the second one. All right, so notice that this equation, the second one is solved for p. And so that means I know that p is equal to 2m plus 10, so that means I can take that and put it into the first equation for p. So let's rewrite that first equation. 2m minus 2 times parentheses 2m plus 10, because that's what I'm substituting in for p, is equal to negative 6. Now remember, when I do this, the whole point of doing this is now I only have m's in my equation. I have one variable, just the m. Now I need to get those m's together, but I just have m. I no longer have p. And so that allows me to go through my solving steps to get p by itself, or to get m by itself. Just like the previous problem, we see a little distributive property here that we can do. So let's do that first. Now that minus 2, think of that as a negative 2. So negative 2 times 2m would be a minus 4m. And negative 2 times 10 would be like a minus 20. So that minus sign kind of goes with that number, and so when we distribute, we have to use that as well. Combining like terms, like we did in the last one, 2m minus 4m, or 2m plus negative 4m, is a negative 2m minus 20 is equal to negative 6. Then adding 20 to both sides, we get negative 2m is equal to 14. Negative 6 plus 20 is 14. And then dividing by negative 2, we get m is equal to negative 7. So we have half of our solution. We've got the m value, and it looks like in the equation the m is kind of like the x value, so I'm going to put that first as our solution, so negative 7. And then to get p, my second equation is 2m plus 10, so I can pretty quickly figure out what p is by then just substituting that into that equation. So 2 times negative 7 plus 10, so that'd be negative 14 plus 10. Negative 14 plus 10 is negative 4. So p is equal to negative 4, m is equal to negative 7. So these two equations should cross at negative 7, negative 4. Let's check that out. See if we did that correctly. I can't use m and p, so I'm going to use x. So 2x minus 2y equals 26 was our first equation, and then our second equation was, let's see, oh, wait a sec, I just typed in the first equation. Let's try that again. 2x minus 2y equals negative 6 was that. There we go. And then the second equation, let's see, is p equals, so that would be y equals 2x plus 10. Let's see, I'm going to zoom out. All right, let's see, those are where we have. So negative 7, negative 4 is where they cross. And that is what we had here, yes, negative 7, negative 4. Okay. Just like the previous page, I think I'm going to skip part C. I'm going to go to part D here. Part D. I have this equation right here is solved for z. So that means I can take that and put it in, substitute it in for z in the first equation, 3w minus 2. So I get 7w plus 3w minus 2, so I'm substituting that in, is equal to 28. All right. Nice thing on this one is I don't have any distributive property. There's no number in front of the parentheses that I need to multiply, but I do have these like terms that I can put together, add those together. So 7w plus 3w would be 10w minus 2 is equal to 28. Adding 2 to both sides, 10w is equal to 30. And then dividing by 10, w is equal to 3. Looks like w is in the first slot here, so I'm going to make w, that would be the equivalent to like the x value. And then I had z is equal to 3w minus 2 is our second equation, so now I can put that 3 in for w, which would be 9 minus 2, which is equal to 7. So z is equal to 7. And move through that fast, but if you're checking your answers here, can pause or catch up, and then we can go and type that in for Desmos. So we're going to use W and Z, we're going to do X and Y, right? So X those out. So let's do 7x plus y equals 28. And then the second equation was z equals, which is my y. So y equals 3x minus 2. And look at that. They cross at 3, 7, which is what my answer was. So good. All right. I think I'm going to stop there and check the 3 answers. If you would like to do part C, then you certainly can try that one. The method that I would use here is to take, since we have 2D equals 8f, then what you can do is in the second equation, you can substitute 8f in for 2D since they're equal to each other. And that is going to be then the equation that you would have. And then you get the f's onto the same side of the equation. So 18 is equal to 12f. And then divide by 12 and solve from there and plug it back in. I'm going to let you guys go ahead and do the rest of that problem. If you do it correctly, then should eventually get a solution of 6 1.5. So see if you can make that happen. See if it turns out to be 6 1.5. And I think that's all we'll do with this page.